Hello, welcome to Vegenaise University. You're going to learn about the science behind Vegenaise. And the first step to learning about the science behind Vegenaise is to learn the science behind an emulsion. An emulsion is a mixture of two different phases, the discontinuous phase or dispersed phase, which is dispersed in the continuous phase or the dispersing phase. Now your product might have a lot of the discontinuous phase and a little bit of the continuous phase, like on the left. Or the image on the right is a little bit of the discontinuous phase and a lot of the continuous phase. And having more of the discontinuous phase, like on the left, will create a thicker product, a more viscous product. Vegenaise, for instance, is an oil in water. So looking at the image on the left, the oil is the yellow circles, and the water is the blue. And Vegenaise has a lot more oil than water, so it's a thick product. But that's not true with reduced fat Vegenaise. Reduced fat Vegenaise has only a little bit of oil and a lot of water. So with reduced fat Vegenaise, we add starch to thicken it up. Now the emulsion has to be stabilized, or else it's going to break. So you might have all those little particles will come together to form large particles called coalescence, or they'll come together and just cling together as clusters of little particles. That's flocculation, or they'll all float to the top. That's creaming. And ultimately, any one of those three situations would turn into breaking, where you just have a large mass of what was the discontinuous phase and another large mass of the continuous phase, totally separate from each other. So we need to stabilize the emulsion to keep that from happening. For Vegenaise, we stabilize the emulsion with the use of protein. The protein forms a coating around a droplet, and that coating keeps the oil droplets from coming together. So how does that work? Well, that coating is loaded with negative charges, and like charges repel each other. Opposite charges attract, like charges repel. So if you have one oil droplet with a bunch of negatively charged proteins on the surface, and another oil droplet with negatively charged proteins, they'll repel each other. But the protein doesn't work that way without having to prepare it first. The protein is prepared first by hydrating it. So to hydrate it, we mix it with water, and it might entail cooking with water. It might entail very high shear blending. It might entail high pressure homogenization. But what happens is the negative charges on the water molecule attract the positive charges on the protein. So the protein has negative and positive charges. So the protein aligns so that the positive charges cling to the negative charges of the water. And now all of the negative charges of the protein are on the surface of the protein. Now I want to talk a minute about overblending the Vegenaise. It is possible to overblend it. Two possible things could happen here. We could have phase inversion, or we could have a rupture of the starch in the case of a reduced fat Vegenaise. So we'll talk about both of these. So for phase inversion, the two phases actually reverse. The continuous phase becomes the discontinuous phase, and the discontinuous phase becomes the continuous phase. So for the case of Vegenaise, where we had the image on the left, where we have a lot of oil dispersed in a little bit of water, they'll reverse, and we'll suddenly have a little bit of water dispersed in a lot of oil. And this is a problem because remember, to have a thick product, we want to have more of the discontinuous phase. So let's talk about the starch. Remember, the starch was needed in the reduced fat vegetanase to thicken the product. It's highly functional, which is good. It makes it a product very viscous, which is good, but it's also very delicate. If it gets too much mixing, it will rupture, and then it'll have no functionality at all. The viscosity will drop. So we don't want to overblend the starch. That's why with the reduced fat vegetanase, we add the starch at the very end, and we just mix it a little bit, and then one pass through the colloid mill just to smooth it out, but not enough to rupture it. So, in conclusion, we know that we need to fully hydrate the protein for it to stabilize the emulsion. And we do that by cooking it, homogenizing it, or blending it with the water before we add any other ingredients. We know that we need to add the oil very, very slowly. So we don't want to overblend the reduced fat vegetanase. If the wet mix is added too early or too quickly, we're going to have an inferior product. It'll probably be too thin. So that's why we have the pump for the wet mix set up so that it pumps at a slow rate. If that pressure is too high and it pumps the wet mix in too quickly, we're going to have a loose product. If we add the wet mix too early, we're going to have a loose product. Okay, so we're going to make original vegetanase. We have our water. This is our dry mix that has the protein and the mustard flour and the salt. This is our wet mix, and this is our oil. So the correct way, we're going to hydrate the dry mix, because that has the protein, in the water. We're going to blend it up to 3 minutes to fully hydrate that protein so it's functional as a emulsion stabilizer, because that's the function of the protein, to stabilize the emulsion. Another thing that's going to be important is when we add the oil, we're going to add it very slowly. And then we're not going to add the wet mix until the oil is almost finished. Okay, that's 3 minutes. Now I'm going to start adding the oil very slowly. Now the oil is about 2/3 finished. I'm going to start adding the wet mix. Yeah, once the wet mix goes in, it starts getting thick right away. But we don't want that to happen too early in the process. I'm going to raise this up a little. That's some good vegetanase there. Okay, now we're going to take the exact same ingredients, our water, our dry mix that has the protein and mustard and salt, oil, and our wet mix. And this time we're just going to kind of blend everything all together real fast. Alright, here we go. There's the dry mix. Just going to dump the oil in. Wet mix.